So hello and welcome everyone. We are live on this particular channel of Unacademy JEE English, and in this session we are going to talk about Newton's laws of motion. In this session we are going to cover complete NLM in one session, one shot, detailed one shot, and it is going to about around 4 hours around approximately. And the beauty of this session is that we'll complete complete NLM. Understanding? Okay, so first of all, let me tell you that what we are going to cover in this session. Will be starting from the very beginning. Constraint motion. Constraint motion is the basics of NLM. People generally cover it as another chapter, but I cover in NLM. Okay, so first of all, we'll cover constraint motion. Then we'll switch on to the laws of motion. First law, and second law, third law, all the Newton's law, Apple, all those things we'll talk about. Then we'll talk about problem solving technique, because in this session it is not just going to be a theory session. We'll talk about like examples also, because NLM is all about like applying the concepts on a particular question. If we don't know that how to apply the particular concept on the pulley or wedge or whatever it is, then NLM is just a waste of time. So we'll just talk about how to solve the problems. Since this is a theory session, we'll talk about the PYQs in some another session also. But in this session, we'll talk about the problem solving technique. Then we'll go about to the Atwood machine, all those blocks, pulley, all that things. Then we'll go to the pseudo force. That is the last portion of this thing. One thing I also want to add in this section, that we are going to cover spring force, all those things in this section. Okay, so hello and welcome everyone, and in this session we are just going to rock on this particular topic of laws of motion, and we'll be starting from the very beginning. Constraint motion. What is constraint motion? Constraint motion is a very important part of our life also. Suppose that I'm coming here, I'm just giving you the class, you are going to the school, you are just repeating all the cycles of the day. That is a constraint. You have a constraint that you'll have to go to the school on a particular timing. The bus will come on this particular, bus is coming, bus is waiting, please come, please come, please come. The sharp 6, the bus is coming. So all these things are the constraint of your life. Similarly, there are some constraint in the physics also, like you are going to office or school, whatever it is, teacher is teaching on a particular subject, suppose that physics on 11 a.m. So this is a constraint of the particular teacher. This is a physics constraint. This is a physics constraint, that this block, suppose that if we are pulling this string, if we are pulling this string in the downward direction, then this block is constraint. Why I'm focusing on the word constraint? Because this is a constraint motion and this block is constrained to move upwards. Because we are pulling this, so it will go up. So this is a constraint motion, and we'll talk about some specific constraint in this particular section. First of all, we talk about the string constraint. What is a string constraint? So first of all, let me tell you one thing about the string. String is what? Some kind of rope or whatever it is. Let me take one string for you. Let me take one string for you. Suppose that this is a string of my charger. This is the cable of my charger. So this is just a string. This is just a string. We'll talk more about this string, but one constraint about the string is, we'll talk some assumption also about this string, that this string should be inextensible. What is the meaning of inextensible? Suppose that I'm pulling this string like this, so this should extend practically. This should extend whether it is a very solid wire or it is a rubber wire. Rubber wire will stretch very much, but on the other hand, that metal wire will not that much get extension. But suppose that this is an ideal string. What is it? Ideal string. So an ideal string will be like, this has a zero extension power. Like if I'm stretching, if I'm pulling it, it will not extend anything, like 0.0000 anything, it will not be extended. So this is called the string constraint. This is called the string constraint, that the distance between 2 points of any string. Suppose that this is a point, suppose that this is a string, and these are the 2 points on this particular string. Suppose that this white wala part and this white wala part, these are the 2 points on a string. So we cannot change the distance between these 2 points. Suppose that A and this B, we cannot change the distance between these 2 points. Understood? So one student can say that, yeah, I can do like this. I have changed the distance between those 2 points, but I'm talking about the pulling. If we are pulling the string, if we are stretching the string, then we cannot change the distance between any 2 points in an ideal string. So an ideal string is inextensible. What it is called? Inextensible. Okay. Other thing you can read also, I'm just telling it. Okay, so this is a string constraint, that the points or the distance between 2 points cannot be changed. And the other thing about a string, that the string, whatever we are talking about, the ideal string, that is a massless string. A string has zero mass. Yeah, also you can watch, if you are in basically 2025, you are going to appear in 2025. This is a one shot, so you can cover, if you have not completed the theory. We are also going to cover the PYQ session also. Okay, so first of all, let me talk about this. So suppose that we have a block, we have two blocks, one is here, other is here, and we have connected it by a string. Now what is going? Suppose that this system is moving in this particular direction. Okay, now all the points, suppose that I have told you that we cannot change the distance between 2 points. Suppose that this is a point A and this is the point B, and suppose that I'll draw it again. Suppose that this is a point A and this is point B. So if point B is going in this particular direction, so point A should also go in this particular direction, because the distance D between these 2 points cannot be changed. That's why this should be, suppose that if the velocity of point B is v1, then the velocity of point B is v2. So we should write v1 is equals to v2 for this particular string. This is a string constraint. So for a general string, for a generic case, we should consider this particular string, that suppose this point is going downward with velocity v2 and this point is going in this particular direction with velocity v1. So what is the relation? Suppose that you have been asked that what is the relation between v1 and v2. So what we will write, that suppose that this angle is, suppose that it is given, I'm giving you that this angle is theta 1 and this angle is theta 2. So what is the relation between v1 and v2? So just what we know till now, that along the strings the velocity of all the points are same. Because why? Because the distance between any 2 points in an ideal string cannot be changed. That's why the velocity of all the points in an ideal string should be same. So suppose that this velocity is v1, so we'll take the component along the string. So this component will be v1 cos theta 1, and this will be v1 sin theta 1. Again break this. So this will be v2 cos theta 2 and this will be v2 sin theta 2. Okay, boss. So now, what are the velocities along the string? Velocities along the string are v2 cos theta 2 along the string of this particular point, and v1 cos theta 1 of this particular point along the string. So let me tell you one thing, that v1 cos theta 1 should be equal to v2 cos theta 2. This is the relation between v1 and v2 in this particular case. So this is called string constraint. Are yes or no? Write in the chat section. Okay, boss. Okay, let us move on to the next thing. Now let us understand one more problem according to this. So till now we have understood that if we have any 2 points in a string, then along the string the velocities of those particular points will be same along the string. Okay, suppose that, let me take one example, that this particular angle, suppose that this is 37 degree. This is 37 degree, and now this particular block is going in this particular direction and this is going in this direction. So what is the velocity of this block? So we'll simply say that if this block is going in downward direction with velocity 2 meters per second, so we can simply say that velocity of this point will also be downward at 2 meters per second. Yes or no? Now suppose that we are going upwards. So this is also moving with 2. 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 So what we can say, that the velocity of this particular block along the plane will be, simply because the velocity of this point will be 2 now. So we'll simply say that the value of v will be simply equal to 2 meters per second. So this was just a time pass problem, nothing else. I'm just trying to explain that how we'll approach to any constraint problem, that we'll just take the value of velocity on a particular point and we'll just transfer the velocity towards all the points of the rope. Okay, now let us take a good example of this particular thing. Now this bucket is going downward with velocity 10 meters per second. So we'll simply say that this point is moving with 10 meters per second. 10. This is also 10. This is also 10. This is also 10. So now we'll simply say that this particular point is moving. Now I'm drawing it other side. So this point is moving in this direction with velocity 10 meters per second. But block has a constraint. Now there comes constraint motion. That block is not moving in this direction. Block is moving in this direction. That's why we'll simply say that the velocity of this particular block, let us say that is v. Let us say that is v in this direction, that we have to find this particular question. Okay, boss. Now this angle is 53 degree. Now we'll simply say that we know that block will be moving in this particular direction. So we will simply say that this particular velocity is 10 meters per second and this angle is 53. So can we write that this 10 meter per second will have a component along this direction. This 10 meters per second will have a component along this direction. So we can simply say 10 cos 53 is equals to v. 10 cos 53 is equals to v. Can we write like this? 10 cos 53 is equals to v. Can we write? Yes or no? No. Why? First of all, you have to recognize where the particle is or where the block is moving. So block is moving in horizontal direction, not in this direction. So what is the principal velocity? What is principal velocity? Principal velocity is the main velocity of the block. So where the block is moving, particularly block is moving in the horizontal direction. So this is the principal velocity. And we always do the components of the principal things. So this is a principal component. This is the principal velocity. So we'll do the components of the principal velocity. So we'll do the components of this v. So along this component, what will be the v cos 53, and perpendicular to this v sin 53. So along this, v cos 53 is equals to 10. So we cannot write like this. We'll have to write like v cos 53, that is equals to 10. So what is the value of cos 53? You'll have to remember these values because these are the most important things in the mechanics, okay? Or in any particular section of the physics. So v cos 53 is 3 by 5 and that is equals to 10. So v will be equal to 50 by 3 meters per second. So this is the value of v. Got it? Clear? Okay, now let us move on to the next thing. Now another example. Let me tell you another example. Suppose that there is a bead. You know, bead, that bead, something round thing, something challa you can say in Hindi also. So there is a bead on any rod, like you have the curtains cut on that, there is a particular bead, okay? So this is connected by a string, and there is a pulley which is fixed on a particular thing, and there is a block also connected with the pulley, with the string, okay? And suppose that on any particular time the block is moving in this direction with a velocity of, suppose that 5 meters per second, and this bead is making angle 37 degree on a particular time t, okay? Now you simply say that this particular block will be moving in the downward direction, yes or no? So this block will go downward and this bead will slide there. This will go down and this will slide. This will do like this, okay? So bead is going in this particular direction, suppose that with the velocity v. What we'll simply say, what we have to find, we have to calculate the value of v. How we'll calculate? So simply you can say that this point is moving here with 5 meters per second, 5. So this is 5 meters per second. Now you have the question like previous one, that the bead is the principal velocity of bead is v, and it is moving in this direction with 5 meters per second. This angle is 37 degree. Now which is the principal velocity? Principal velocity is v. So we will do the components of v. What is the components of v along this? So v cos 37, that is equals to 5. So v into 4 by 5, that is equals to 5. So v will be equal to 25 by 4 meters per second. Yes or no? Clear? Okay. Now let us move on to the next thing. Now second format, pulley. What is pulley? We can simply say will be dealing with the ideal pulley. With an ideal pulley we'll be dealing with. Okay, what is an ideal pulley? First of all, I'm telling about you the pulley. So any pulley you are talking about in the physics or particularly in mechanics, So it will be given that this is ideal. And what is the meaning of ideal? Ideal pulley has two things. First of all, that pulley will be massless, and ideal pulley is massless. So pulley is ideal pulley. Ideal pulley. Ideal pulley is massless. First of all, it is massless. And second thing, it is frictionless. Second thing, it is frictionless. Frictionless. So an ideal pulley is massless and frictionless. Now what we have to deal with, we have to calculate, or we have to find a relation. If a pulley is moving, if the blocks are moving, we have to find the velocity, we have to find a relation between all the velocities of the block and the pulley, as well as all the things. Okay, so suppose that this pulley is moving upwards with velocity Vp, where P stands for pulley, and this block is A, this block is B. So this block is moving, suppose at velocity Va, and this block will be moving with velocity B. Now you'll have to think a little bit, and we have to find a relation between Va and Vb. Got it? Okay. Now, how there are a lot of methods. First of all, I'm just applying a simple method. How we'll find the relation between a pulley and the velocities of pulley and the block. So suppose that you are an aunt. Not that aunt, uncle aunt, fella, not aunt. This is your aunt, like the small aunt. Okay, and you are sitting on the pulley. If you are sitting on the pulley, then the pulley will be at rest for you, because you are sitting on a pulley. Like on our earth, we are sitting on earth. That's why earth is at rest for us. Okay, so it is simply like looking like that this particular pulley is at rest for that particular aunt. Okay. Now, what it is seeing, that I am suppose that sitting on the pulley, and I am seeing that blocks are moving, because pulley is also moving, blocks are also moving. Since I am sitting on the pulley is at rest for me. Now only the blocks are moving for me. So what will happen? Suppose that there is a rest pulley. Just imagine. Just suppose that there is a rest pulley, and there are two blocks on the pulley. There are two. This is the rest pulley. Okay, this is rest. Okay. Now there are two blocks attached with the pulley. Okay, now suppose that this block is moving downward. Suppose that this block is moving downward. This block is moving downward with velocity V. Where this block will go? Can we say that this block is constrained to move in the upward direction with velocity V? This is constrained to move in the upward direction, since the pulley is fixed. Here the pulley is fixed. Okay, here the pulley is fixed. Okay. If the pulley is fixed, then these blocks are constrained to move opposite to each other, because this is going downward, so it will automatically go upward with the same velocity. Now, come to this particular section. Since the pulley is moving, but we are sitting on the pulley, then we can say that, that particular aunt is sitting on the pulley. So that aunt can say that the pulley is at rest for that particular aunt. Okay. Now, what that particular aunt is seeing? It is seeing that one block is coming upwards. Okay. If one block is coming upwards, then what the other block is doing for that particular aunt? It is constrained. Since the pulley is at rest for that particular aunt, then those blocks are constrained to move opposite to each other. Since that block is coming upwards, so it will go downwards. It means velocity of the block A with respect to that aunt or the pulley. So velocity of A with respect to pulley is suppose that upwards. So velocity of B will be downwards with respect to pulley, but since there is an opposite direction, so there will be a negative sign. So we can write velocity of A with respect to pulley is equals to velocity of B with respect to pulley, but with a negative sign, because one is coming upwards and other is going downwards. Okay, so this is relative velocity. We have already studied in the kinematics that velocity of A with respect to B, that is equals to velocity of A minus velocity of B. So we can write here velocity of A minus velocity of pulley, that is equals to minus time velocity of B minus velocity of pulley. Just solve it. What we'll be having with? We will be having with VA minus VP, that is equals to minus VB plus VP. Okay. So Vp comes there, and it will become Vp is equals to Va plus Vb. So Vp will be equal to Va plus Vb by 2. So this is a relation between the velocity of pulley. This is the relation between velocity of pulley and velocity of the blocks. Clear? Yes or no? Okay. Now, since we have found a relation, but just imagine one thing, that we have found this particular relation if we have just one pulley and two blocks. Suppose, and they are moving. Suppose we have three pulleys, 6 blocks, all the things are like changed, we cannot apply like this. So we'll have to do an alternative for that particular kind of problems. Means we'll have to find a solution if we have lot of pulleys and lot of blocks. So what we'll be doing with that particular kind of things, first of all, let me tell you one thing, that how we will dealing with the problem. We'll be dealing this problem not with this particular method, we'll be dealing with a lot of pulleys wala method. So I'm just going to tell you that how we'll be handling this kind of problem with very ease. So I just call it very short trick. This is not just a short trick, this is just a concept, but this looks like a shortcut or short trick because it just looks like a magic. Yeah, it is going in this particular direction, so just take negative, positive. It looks like a short trick, but this is not actually a short trick. Okay, so what is it? Just look at this figure. There are a lot of pulleys, lot of blocks. So how will we be dealing with this? What we have to do in this particular kind of trick, we'll have to select a string on which we have to apply the trick. Okay, so suppose we'll be basically considering the main string, whatever it is in a particular system. So in this particular system, the string is this wala string. This string is the main string you have to consider. Okay, now suppose that we have to find the relation between all the pulleys and all the blocks. Suppose that the velocity, I mean, now I'm not saying that the velocities are given. Suppose that this is VA, this is VB, and suppose that this is VC. Okay, now we have to find a relation between VA, VB and VC. Got it? Now, how I'll be solving it? First of all, you'll have to mark the points which are connected. Like suppose, likewise, this point is connected with the upper ceiling. Okay, now come to the other point. This point, we have to consider the edge points, or we can say. So this particular point is connected with the pulley. Now these are all connected, so we'll not consider. We'll just consider the edge points. So what is other edge point? This is another edge point. This is another edge point. This. Okay. Now. Other point. This is another point. This point, and this point. These are all connected points we'll have to consider. Now, what is the short trick? The short trick says that just look at all the points which are connected, which you have marked. Now look at the motion of those points. In which direction those points are moving. If the point is moving in such a way, which way? If the point is moving in such a way that it is increasing the length of the string. If it is moving in such a way that it is increasing the length of the string, then we can simply say that we'll consider the velocity of that particular point is positive. Got it? And if the point is moving in such a way that it is decreasing the length of that particular string, then we'll consider that particular velocity as negative. Got it? Now consider all the points. Since this point is at rest, we'll consider it as 0. Because it's not moving. Now this block is moving in downward direction, so pulley is also moving in downward direction. It means this point is also moving in downward direction, this point is moving also in downward direction. So first of all, we consider this particular point. So this point is moving, since the pulley is also moving with VA, so this point will also moving with VA in downward direction. And look at this point, look at this point. This point is stationary, this point is stationary, this A wala point is stationary, and this B point is moving in downward direction. This B point is moving in downward direction. Just look at the length of this string. Just look at the length. This point is moving downwards. So what the rope is or what the string is doing, the string's length is increasing. It means this velocity is positive. So this VA is positive, plus VA. Similarly, this is also moving in downward direction. Length is increasing, so plus VA. Now go upwards. This point, since the pulley is connected with the ceiling, this is fixed. This is also fixed. Since this is moving in the downward direction, so again VB plus VB. Now come here. What VC is doing, since it is going now, these are also fixed points. Now last point is moving in upward direction with velocity VC. So the length will be decreased, means minus VC. That is equals to 0. This is the trick. This is how you will write the relation between all the points, between all the velocities. Okay, got it? Give me a minute. Okay. Now what we can write it? 2VA plus 2VB. Now just the calculation. Minus VC, that is equals to 0. So this equation we have got, or we can say this relation we have got in these three velocities. Now give me one sec. That we have given that this block is moving downward, this block is moving downward with velocities. We have been given these velocities. So just put the values of these 5, 2 or whatever it is. So 2 into 5 plus 2 into 2 minus VC we have to find out is equals to 0. 5 2s are 10, 2 2s are 4 means 14 minus VC, that is equals to 0, means velocity of C, that is equals to 14 meters per second. 14 meters per second. So this is the velocity of this block C in the upwards direction. Got it? Got it till here? Any doubt, any confusion? Should we move on to the next thing? So now we'll be dealing with the previous problem which we left. Okay, now what the question is saying? The question is saying find the velocity of block B. What is block B? This is block B. At any instant shown in the figure, at any instant, we have to know that at this instant, because when the angle is 37 degree, we have to calculate the velocity of this block B. Okay, now suppose the velocity V is moving in this direction with V. This B is moving with V. Okay, now we will just take the component. So the component of velocity V in this particular direction is V cos 37, and in this direction V sin 37. V sin 37. Okay, now this is 10. Now what we have to do, we have to apply the simple procedure which I have told in the last slide, that point the mark the point. This, let me draw with the other color. This. Got it? Now just look at the motion of all the points. Just look at the motion. This point is at rest, means velocity is 0, plus this block is moving. This block is moving downwards. So this particular pulley is also moving in downward direction with velocity 10. So plus 10 plus 10. So plus 10 plus 10. Okay. Now this pulley is fixed 0 0 0 0. Now it is coming in this particular direction with V cos 37 and the length of the string is decreasing, means minus V cos 37, that is equals to 0. So V cos 37, that is equals to 20. What is cos 37? Cos 37 is 4 by 5, means V into 4 by 5, that is equals to 20, means 4 5s are 20. So V will be equal to, V is equals to 25 meters per second. 25 meters per second. What is the correct answer? Correct answer is A. Correct answer is A. Got it? Should we move on to the next thing? So this was all about that particular kind of constraint of string. Okay, let me give you another question. So you'll be confident about that. Okay, suppose that we have a problem like this. This is a very famous problem. Of SC Verma or whatever the competitive exam, you have at least once you have seen this problem in your life. Okay, so suppose that this block is A, this block is B, this block is C, and this block is moving with VA, VB, and this block is moving with VC, this block is moving with suppose that VA. We have to find the relation between VA, VB and VC. How will be solving this? So first of all, the procedure is same that I have told you already in the last 2 slides, that what we have to do, we have to select a string and we have to mark the points. So first of all, we are selecting this string, this wala string we are selecting. Okay, so first of all, mark the points. So this point is, so first of all mark the points, then we'll talk about that. So since this block is moving with the VA, so and this block is at rest, and suppose that velocity of pulley, this is the velocity of pulley. Okay, so this point minus VA, 0 0 plus 0 plus 0. Now the pulley is moving with the VP and length is increasing, means velocity of P is equals to 0. So velocity of P is what? Velocity of A. We could also write it in a simple manner that if this velocity is VA, so velocity of pulley will be also VP, but we have also calculated it. Okay, now just consider on this particular system. Now we have to consider on this system. So this system is what this system is doing. This system, the pulley is moving with VA, this is moving with VB, no, this is moving this direction, this is moving with VB, and this is moving with VC. Correct? Now we will write the relation between VB, VA, VB, VC, VC, whatever it is. Okay, whatever it is. So mark the points A, B, C, D. What the points are, just let it be. So now we will write VA, VB, VC. How we'll write? We will simply write that this is moving downwards, length is increasing, plus VB. No worries, plus VB. This is moving downwards with velocity VA and length is decreasing, so minus VA. This is also minus VA. This is moving upwards, so length is decreasing again, so minus VC, that is equals to 0. So we can simply write VB is equals to 2VA plus VC. This is the relation between VA, VB and VC. Got it? Got it? So this is a relation, and this is going to help you in solving the laws of motion problems also, because constraint motion is a part of NLM. Constraint motion is a part of NLM, and it helps in all the problems of pulley block system and wedge block also, but we are talking about the pulley block right now. So it helps in all the pulley block problems. You cannot solve any NLM problem of pulley block without constraint motion, because there will be an equation like this, any acceleration equation like this, and that will help you in solving that particular equations of the NLM, that free body diagram, if you have heard anything about that particular thing. Okay, so you'll have to understand one thing, that we are applying this for the velocity. We can also do the same for acceleration also. Suppose that we have been given the acceleration, the block of the acceleration of this block A is AA. Suppose this wala AA, this wala AA, or A1 you can say. So A1, A2, A3, and now you have to find the relation between A1, A2 and A3, or AA, AB, AC. So you will simply solve it like this. Just instead of velocity, you will just put the acceleration. All the things are same. All the things are same. You will just solve all the things. Now this equation will help you in solving the NLM problems. Got it? Now let's move on to the next thing. This kind of problems is also asked in this particular section. So how will be solving? This is one of the good questions. Okay. So we will have to find a relation between A and B. We'll have to find a relation between A and B. How will we be solving that? So look at this. Look at this. Suppose what the points are doing, we'll have to just mark the points. This, and this. Okay, now what this wedge is doing, this particular block B is doing, this block is going in this direction with some, you can say this B is velocity or acceleration, whatever you want to say, you can say this to B, as well as for A also. This can be acceleration, this can be velocity, it can be anything. Okay, now since the velocity of this particular wedge is B in this direction, it means pulley is also moving in this direction with velocity B. Now we'll have to focus on the pulley. This is pulley. We have marked these 2 points, this point and this particular point. These are connected points. Okay, now since this point is fixed, we will not focus on that particular thing. So this point is moving here with velocity B or acceleration B, whatever it is, and this is also moving here with velocity B. Okay, now other points is this. Okay, so other point is this. Now since this is moving here in this direction with A, and it is also kept on this wedge, it means this block is also moving in this direction with velocity B, with velocity V, and this angle is theta. So this angle is also theta. And I have told you one thing in the constraint motion, that velocities of the points, any 2 points on the string, is same in the direction of string or along the string. So what are the components of these velocities along the string? First of all, this is along the string because a string is like this, so this is B, simple B. Okay, and this is just reducing the length of the string. It means minus B. I'll write it here. In simple terms, this is minus B. Okay, now come to this point. This point is moving in this direction with velocity B, so we have to consider the component of this particular velocity along the string. So what is the component of velocity along the string? This. So this is B cos theta, and this is moving in this direction, so length is increasing, means plus B cos theta. Okay, next thing. Now this block, just consider on this particular point. This point in this direction also and this direction also. This is B and this is theta and this is A. Correct? So this is B cos theta. And this is B sin theta. So we just focus on the component along the string. So this is B cos theta and this is just decreasing the length. It means minus B cos theta. And this is moving in downward direction. So length is increasing, means plus A. And that total is equals to 0. You can say simply that B cos theta got cancelled, minus B plus A, that is equals to 0. It means A is equals to B. Got it? So this is the relation between any two velocities or acceleration, whatever you want to say. You can say simply that this is a relation between A and B. Okay, let us move on to the next thing. This thing I have solved. Now we'll come to the wedge constraint. What is wedge constraint? First of all, we'll talk about that. Suppose that I have this particular notebook. And I have something like this particular wedge, you can say, and this particular is block. Okay, so if we leave this block, this is going in this direction. And one thing you'll have to understand, that if this is moving in this direction, it means it is applying also normal in this direction. So if I remove this hand, it can also go in a particular direction also. So if we leave this system, like this, if this is going in this direction, suppose that with acceleration or velocity A, and this is going with velocity B, so one thing we'll have to realize that this B and this A are connected, something, they have some old relations, so they'll be connected with each other. Okay, now how we'll find the relation between them? So first of all, let us say this angle is theta. Now we have to find the relation between A and B. Got it? Okay, how we'll find? First of all, look at the contact, that contact boundary, or whatever the that contact surface. This is the contact surface. This is the contact surface between these 2 points, or I'll draw with some other color. This is the contact surface, right? This is the contact surface. Okay, now just look at one thing. Just think, can this particular block, can this particular block penetrates in this particular wedge? Can this particular block be penetrated in this particular wedge? No, because these are solids and these are like rigid bodies. We are talking all about the rigid bodies. So this cannot penetrate into this particular system. It means the velocity, means along the surface, or we can say perpendicular to the contact surface, whatever the velocity of this particular wedge is, the same should be the velocity of the block. What I'm saying is that the velocity of this particular system perpendicular to surface should be equal to the velocity of block perpendicular to the surface. It means suppose this particular surface, I'm drawing this surface here, this is the surface, or I'll be writing with some light color. This is the surface, this contact surface, I'm drawing it here. Okay, now upper portion is this block, lower portion is this wedge. Okay, this is A and this is B, so this section is A, this section is B. Okay, now this is the surface, so this block cannot enter into another block, right? Because these are the solid things, these are rigid bodies, and this system is moving in this direction with acceleration or velocity A, and this system is moving in this direction with velocity B. This wala. Got it till here? Now, can this block penetrate? No. One thing we know, this angle is theta. So what we can say, that the velocities along the perpendicular to the surface, will be equal. Velocities along the perpendicular will be equal. It means we'll just draw a perpendicular here. Got it? Oh, one thing I have just written mistakenly, that this block, if we are sitting on this wedge, if we are just look at this, if we are sitting on this particular wedge, then according to me this block is sliding this way. But if we are seeing from the ground, this block is going in this direction as well as in this direction too. Means with the wedge. So collectively this block is going in this direction and this direction as well. So we'll be saying that this block is going in some downward direction. Suppose that with A, or where should I write this A? Okay, so direction of A is what? This direction is A. Okay, now we have to find the relation between A and B. So this is A, this is A and this is B. And look at this angle is theta. And if this angle is theta, this angle is 90 minus theta, and if this is 90 minus theta, we can simply say this is also theta. So this is theta. It means we have to find the components of A and B. Means the component of B is, this is B cos theta and this is B sine theta. Similarly, this is B cos theta, and this is B, sorry, this is A sine theta, right? This is A sine theta. So, A cos theta, and this is A sine theta. And what I have told you, I have simply told you that these blocks cannot enter into each other. It means the velocities perpendicular to the contact surface should be same. It means the B sine theta should be equal to A cos theta. B sine theta should be equal to A cos theta. It means we can write that A is equals to B sine upon cos is tan. So B tan theta. This is the relation between A and B. This you have to just understand that how we are going, or how we are reaching up to this relation. Got it? Yes or no? Okay. Now this is the same thing you can try, that if this block is going in this direction, this block is coming downwards. So what is the relation between U and V? Simply you can write U is equals to V tan theta. I'm not writing it because it's the same. Okay. Okay. Now till here we have completed the constraint motion problem, like how the blocks are moving, how the pulleys are reacting, how we can find the relation, because constraint is the major portion before starting the NLM. Now we are officially entering into the Newton's laws of motion, and we'll be starting with simple force. What is force? We simply say in our childhood or in our 9th 10th also we have studied that that particular force is something like push or pull. If we are this Dadaji or some kind of grandfather, we are just pulling it. So this is a kind of force. We are applying force in this particular direction. We can also push. So force is simply push or pull in any random direction. Okay, that is force. Now unit of force is simply Newton. We don't have to spend too much time on this particular thing. So unit of force is Newton. So force is simply which we are just some pulling or pushing, whatever it is. Okay, now this is going in this direction, so this is force. Okay, we don't have to spend too much time on this particular thing. Now what our thing is, where should we focus? We should focus on the type of forces. We have specially 4 types of forces. One is electromagnetic force, second is gravitation. These are 4 fundamental forces. So gravitational force, electromagnetic force, contact force, and nuclear force. Okay, so whenever we are saying about the forces and laws of motion, we divide this chapter into 2 things. One is normal NLM without friction, and one is NLM with friction. So in this session we are covering the NLM without friction. In other session we will be covering NLM with friction. So in this session this is contact force, and contact force is of 3 types. One is normal reaction, second is we'll be understanding whatever the forces is. So normal reaction, tension, and friction, these are 2 kind of forces. These 2 forces, tension and normal reaction, will be dealing in without friction, and other is also friction, so that will be dealing in the next section. Okay, and last but not the least, that is nuclear force, that will be dealing in the 12th in the nuclear physics, or we can say the modern physics. Okay, that will be dealing later. Got it? So we'll be dealing with the normal reaction. So first of all we'll be starting with the normal reaction. What is normal force? So suppose that we have a particular body. Suppose that we have a particular body like this, and this body is kept on a particular surface. So we'll be saying that this particular body, this adapter is at rest. Yes or no? This adapter is at rest. Suppose that if we remove the surface, this adapter will go down. If we remove the surface, this adapter will go downwards. Okay, got it. So why this is stationary and at this particular point? Because there is a force in downward direction on this particular block because of that gravitational attraction, and that acts downwards. And how we'll be writing? Simply how we'll be writing it as m into g. How we are writing this mg? Force into acceleration. We will be deriving this equation also. So this is mg, and we'll suppose that this is gravitational force. We'll be defining it later. Okay, this is gravitational force, and since this is at rest, it means all the forces on this particular block should be cancelling each other. That's why this block is at rest. So if a block is at rest, we'll simply say that all the forces are cancelling each other. It means if this is downwards, there should be a force in upward direction that should cancel this particular gravitational force. It means there is a force in upward direction. What is that force? That particular force is normal reaction. That particular force is normal reaction, your normal force. And this is denoted by N. Sometimes it is also denoted by R. Okay, so normal cancels this mg or gravitational force. So we should say that this normal is cancelling mg here, or we can say if two blocks are in contact. This is not just applicable on mg or gravitational force. Whenever these two surfaces are in contact, or I am just pulling this board, or I am just pulling my mouth, or this thing is pulling it, this thing is pushing this thing in this particular direction, so we will simply say that these two surfaces are applying normal reaction on each other. These two surfaces are applying normal reaction to each other. If two bodies are in contact, then they should apply normal reaction. On the direction of the normal is what is direction? Direction of normal is perpendicular to the surface, perpendicular to the contact surface. Perpendicular to the contact surface. Got it? Any doubt till here? Okay, yes or no? Should we move on to the next thing? Okay, now this is normal reaction. Now we'll be dealing with some some abnormal things. This is not the normal, this is normal reaction force. Because in normal, just like suppose that this is a question that this block is at rest on this particular surface, you have to find the direction of normal force. So where the normal is being applied on this particular block, so this block is applying mg in this direction, and this surface is applying normal direction upwards, the in upward direction and perpendicular to the plane, so perpendicular to the contact surface. So this is a simple thing. We can find normal in this system very easily. But in these kind of systems where we don't know what is the direction of normal, how we'll finding? Because there are not like very simple cases. Okay, now we'll be starting with the first thing. Suppose that there is some wall and there is a ladder connected with it. So how will we writing the normal reaction on this? Suppose that we have to write the normal force on this particular ladder. We have to write the normal force on this ladder. So what is the direction of ladder? What you have to do? First of all, you have to find the contact point. This is the contact point, and you just have to find the surface which is extended towards that normal point. Which surface is extended? This surface is extended. This surface is extended. This wala surface is extended towards the normal point. And now you have to draw a perpendicular normal to that particular surface which is extended. So what is the direction of perpendicular? Direction of perpendicular is this. So this is the normal reaction on this particular ladder. Similarly, on this particular point, this is the contact surface, or this is extended surface, and this is the normal reaction. So suppose that this is N2, sorry, this is N1, so this is N2. Got it? Any doubt? Now, similarly here, on this particular point, we can simply say this is like this. So this is the extended surface, this is the point, and this is a normal. But on this particular point, the ladder is kept like this. So this surface is not extended surface. In this case, this surface is extended surface. So this is the normal reaction. We have to just draw the normal or perpendicular to the extended surface. Got it? Should we move on to the next thing? Now there comes a bit tricky thing. Like these are the two ladders like this. Now what is the direction of normal? If there is such kind of thing, then the normal is variable. You can consider normal in any two random direction. Suppose this is the ladder. Okay, got it? This is the ladder, and this is the contact point. So you can just randomly think that this is the two directions of normal. What is this? And one is this. This is the actual procedure that you have to consider two directions. One is nx, and one is ny. And this we will be dealing in the rotation thing. We will not be dealing this kind of problem in this particular section. Okay. Now just look at one problem, that how we'll just find the normal reaction on the particular block, whatever it is asked. So first of all, read the problem, that two blocks are kept in contact as shown in the figure. Find, first of all, what you have to find? We have to find the forces extended by the surfaces. So all the surfaces we have to find the forces. So first of all, this 10 kg block. Okay, on the blocks. Okay, so this is the first block, and 10 kg. This is the 10 kg, and we have to find the forces by the surfaces, So first of all, this surface, this ground wala surface is applying normal direction in upward direction. So this is normal. Suppose at N1. So this is applying downwards. Mg means 10 into 10. What is the value of G? That is 10. So 10 into 10 means 100 Newton. 100 Newton. So N1 is equals to 100 Newton. There is no such force. There is no another force in this vertical direction. Now in horizontal direction, there is a force 100 Newton. There is a force 100 Newton, and there is a normal reaction by this surface, by this 20 kg block on this direction. So suppose that this is N2. So we can simply write, since this block is at rest, we can simply write that N2 is equals to 100 Newton. 100 Newton. So we have got N1 and N2. Now, on that particular block, this block is there 200. That is mg. This is suppose at N3. This is N3. Suppose that this particular wall is applying N4. This block is applying N4, and this 10 kg is applying N2, because that is applying N2 on this. So this is applying N2 on that. We will talk about this in the external direction pair. Okay. So this is N2. And one more force, this 50. So we'll have to do the components of this 50. So 50, this is 50, and this is 30 degree. So this is equals to 50 cos 30, means 50 into root 3 by 2. And this is 50 sin 53, means 50 into 1 by 2. Got it? So there is a force on this block, on this direction, that is 50 into 1 by 2 means 25 Newton. And this is another force in this direction, that is 25 root 3 Newton. Okay, so what we can write? We can write N3 is equals to this. So N3 is equals to 20 root 3 plus 200. So this is the value of Newton, whatever it is, and you can simply, you know the value of N2, you can find the value of N4 as well. Any doubt till here? So you can solve further as well. Okay, got it? Now we'll move on to the next thing. Okay, what the next question is saying? Next question is saying that calculate the normal by both walls, if the angle between them is 37 degree. Suppose that this angle is 37 degree. This angle is 37 degree, and it has not given the mass. So I'm just assuming the we'll have to this should give a mass. So I'm just assuming the mass is suppose that 2 kg. 2 kg. Okay. Now, what is the direction of that particular normal applied by these particular surfaces? So what I have told you, that you have to find first of all the contact point. What is the contact point? This is the contact point, and this is the contact point. And what is the extended surface of this particular contact point? So this is the extended surface, and this is the extended surface. So these are, and we have to draw the perpendicular along the extended surface, or sorry, along the perpendicular. Okay, perpendicular. So this is suppose at N1, and this is suppose at N2. This is suppose at N2. Okay. And one more thing. There is a mg in this particular block, which is 20. Got it? Now. This total angle is 37 degree. It means this angle is 90. This angle is 90. So this is what? 53, and this is what? 53. This is what? 53. So simply we can write this is also 53 and this is also 53. Aligned? Okay. Now we will just write these things. This is 20. This is N1. This is N2. And these angles are 53 degree and 53 degree. Okay. Now. Any doubt till here? No. So we'll just break these N1 and N2 into its components. So this is what? N1 cos 53. And this is equals to N1 sin 53. N1 sin 53. Similarly, N2, this is N2 cos 53, and this is N2 sin 53. N2 sin 53. So since this block is at rest, this particular ball is at rest, so these forces will be equal, means N1 sin 53, that is equals to N2 sin 53. N2 sin 53, sin 53 got cancelled, N1 is equals to N2. Similarly, in the vertical direction, this total force is equals to this total force, means N1 cos 53 and N2 cos 53, and N1 and N2 are equal. So we'll just simply write it N1 and 2N1 cos 53, that is equals to 20. So we can write that 2N1 cos 53 is 3 by 5, that is equals to 20. So this is 2 10s are 20. So N1 is equals to 50 by 50 by 3. Similarly, N2 is equals to 50 by 3 Newton. Newton. Don't forget to write the unit. Never forget to write the unit. Got it? Any doubt till here? Should we move on to the next thing? Okay, let us move on to the next thing. Suppose that this is the block. This is the this is a good problem, one of the good problems. Okay, so now there is some data also given here. So this distance is 1 meter, this distance is 1 meter, and this distance is 3 meter. It is given. Okay, and the radius of this particular block is, this particular sphere is 5 meter. Okay. Okay. We have to find the directions of the normal also. We have to find the directions of the normal also. So there is just this contact point, and we have to find the normal. So we'll simply say that this is the suppose the tangent. So we'll simply say that this is the direction of normal. This is direction of normal. So this is N1, and similarly this is N2. This is N2. Got it? Any doubt? Okay, now we have to find the angles also, because there is no angle given. This is some data given. Okay, so just look at this. This is 5 meter. This is 5 meter, and this is the contact point, and this is 3. This is 1. So this distance is 3. This distance is 3. I'm not writing this here 5. Okay. So this is 3 meter, and this is, or I can write it here also, because it will look good. So this is 3 meter, right? This is 3 meter, and this is 5 meter. So if this is 3, this angle should be 53. Sorry, 37. So this should be 53. Similarly, since this is 3, this is 1, so total is 4. So this, it is here. Okay. So this total is 4. This total from here to here, this is 4. If this is 4, I'm just drawing this triangle. This is 4, this is 5, so this will be 3, and this angle will be 37, and this will be 53. Leave it. So this is 37. So I'm just writing the angles, that this is 37 and this is 53. This is 53. Okay. So simply we'll just draw this. So this will be 53 and this will be 37. Now this is a good problem. Now we'll just do the same procedure we have repeated in the last problem, that we'll just break down these normals into its component, that n1 cos 37 in this direction, and on this particular point there is n1 cos 37, and also n2 sin cos 53, n2 cos 53 in this direction. N1 sin 37, and in this direction n2 sin 53. And in this direction, what is the mass? This is 10, so this will be 100. This will be 100 Newton. Got it? Any doubt? Now n2 sin 53 is equals to n1 sin 37. It means n2, what is sin 53? It is 4 by 5. That is equals to n1 sin 37, means n1 into 3 by 5. That is n1, and this is n2. Sorry, this is n2. So n2 into 4 by 5, that is equals to n1 into 3 by 5. 5 got cancelled. What we'll be left with? We'll be simply left with that n1 is equals to 4 by 3 n2. 4 by 3 n2. So what is the other equation? Other equation is vertical equation. Means n1 cos 37 plus n2 cos 53, and that is equals to 100. Now you just have to put this relation into this equation, and you can solve these equation for n1 and n2. Any doubt? Should we move on to the next thing? Okay. Next, this is a solution. You can simply see. Okay. Now let's talk about the tension force, because this is the one of the major forces we are going to talk about. Okay, what is tension force? Tension force is, I've already told you in the beginning of the session, that tension force is something when we are just pulling the string. If we are pulling the string, just go now. Yeah, now this is good. So just look at this string. My boys and girls. So if this is a string and we are just pulling this string apart from each other, like this. Now there is some extension, there should be some extension in the string, but since this is an ideal string, so this is resisting, this is resisting that force to stay close to each other. If this is inextensible string, then this is resisting that particular force to stay with each other, and that stress is creating the tension in this string. The stress is creating tension in the string. So if we are pulling these F1 and F2, so this is just trying to stretch like this. This is also applying here T1, this is also applying T2. Okay. Suppose that the mass of this particular string is m. Whether the ideal, if we are talking about the ideal string, I've already told you that the string should be massless and inextensible. But let me tell you one thing, that since we are just marking these tensions as T1 and T2, so I'm just doing an experiment to show you. That how this T1 and T2 are equal. Okay. Now just look at this tension. Just first of all look at this particular rope. This is the rope. This is the string or rope. This is the string. And there is tension T1 and it is T2. This is T2. Or we can simply say that there should be a tension, or this is pulled by this direction. So this is T1 and this is T2. Okay, because this is at rest, this string, or we can say, okay. So we can simply say this string is massless. We will have to just notify this thing that string should be massless. Now we'll be finding the relation between these tensions T1 and T2. So we can simply write the force equation. What the force equation is? The total force is what? T1 minus T2, that is equals to mass into acceleration. What is mass? Mass is 0. It means T1 minus T2, that is equals to 0. So T1 is equals to T2. This is the relation between the tensions. This is the relation between the tensions of the string. So the tension in string will be same for all the points. So we can also say that all the tension of all the points in a string is same. So we will not write T1 and T2 if this is a block. If this is the block and these are pulled by this thing, so we'll be writing this T and this T. These are the tension forces. So this is same in the direction. Okay, now let's move on to the question. So this is the first question. This should be connected. Okay, what it is saying? It is saying this angle is 37 degree. The system shown in the figure is in equilibrium. Find the magnitude of the tension. In each string. We have to find the tension in each string. So suppose there are three kind of strings. This is first string. So suppose this is T1, this is T2, and this is T3. Okay, this is T3, and this block is being pulled in the downward direction with 400. So this is 4 kg na, so 40 Newton. This is 40 Newton. Now look at this block. Just look at this block. This block is saying that I am being pulled in downward direction with this 40 Newton. Since I'm stationary, then there is a tension in upward direction aligned, and that tension is T3. So we can simply say that T3, that is equals to 40 Newton. And now we have got the value of T3. So if this is T3, so upward tension is also T3. Okay. So now come to this particular point. So on this particular point, we'll write all the forces. This particular point, we are writing all the forces. So that is T1. This is T1. This is T3. And this is T2. Got it? And this angle is 37. So this is 53. Okay. So if this is T2, so this will be T2 cos 53. Got it? And this is T2 sin 53. Right? Now since we have found the value of T3 and that is equals to 40 Newton, so we'll simply write that this block or this point is also at rest. So we'll simply say that upper force is equals to lower force, means T2 cos 53, that is equals to 40, means T2 into 3 by 5, that is equals to 40, means T2 that is equals to 4 5 is 20, means 200 divided by 3 Newton. So this is the value of T2. Now we have found the value of T2. Now what is remaining? What will be left with? We have to just calculate the value of T1. What is T1? This is what I have written. This is T1. This is T1. This is T1. How can I do such kind of mistakes? This is T1. So this is cos 53. This is T1. So T1 sin 50. This is T1. This we have found T1. Okay, so T1 cos 53, T1 into 3 by 5, so T1 is equals to 200 by 3 Newton. Now we have to find the value of T2, and T2 is saying that I am equal to T1 sin 53. So T2 is equals to T1 sin 53 means T1 is what? 200 by 3, and sin 53 4 by 5. 4 by 5. So this is got cancelled. 4 means 160 by 3 Newton. Any doubt? Any doubt? Previous question. What was previous question? There is no previous question. I was just explaining the concept. So this is the question which I'm talking about. So this is the values of tensions in all the strings. This is T1, this is T2, this is T3. Got it? Should we move on to the next thing? We should move on to the next thing. Now we'll just move on to the Newton's first law of motion. We have also learned in our childhood that what is the first law of motion. Newton's first law of motion is the law of inertia. Will also say we will not spend too much time on explaining validated that explanation. I'm not going to talk about that. I'm just simply say that Newton's first law is if a body is moving, that will keep moving in the particular direction if we will not apply a force. Similarly, if a body is at rest, that body will remain at rest until unless we apply a particular force on that particular body. So this is first law of motion, and this is also called the law of inertia. Means the body is moving, it will keep moving until unless we apply an external force over it. Okay. I'm not going into too much details of this. We'll just simply move on to the linear momentum, because we have to understand that particular second law of motion. So suppose that we have a block. Okay. Now if we have two blocks. Suppose that these are two blocks. This tiny thing can you see on the shadow? Can you see? Yeah, you can see. So we have two blocks. One is this, one is this. If I throw this block towards you and it just gets just hit your head, what it will impact? If I'm throwing like this, if I'm just throwing like this, it will just do nothing. But if I take this and I just throw it on your head, what it will do? It will just simply just nothing, just some makeup of red things on your face. It will just do some makeup on your face, right? So you will just just injured, right? So if I'm throwing these two things with same velocities, why this thing will hurt you more? Because this has more mass and this has less mass. Okay. Since there is another experiment that we have two equal things. We have almost two equal things of same masses. One is this, one is this. So almost the mass is same. Okay. One is throwing like this, just a small thing, a small velocity, and one is like this. So which will hurt you more? If I'm throwing it a large velocity, or we can say it will not hurt you more because I'm throwing it a very small velocity. Aligned? Okay. So if I'm throwing a particular thing, if a body is moving, so two things matter in that particular body. One is mass and second is velocity, that how much the mass is and what is the velocity of that particular mass. So the combination of mass and velocity becomes momentum. Momentum is what? The multiplication of mass and velocity. So you can also take the example of a cycle and a truck. If these cycle and a truck are moving with the same velocity just hit you, which will hurt you more? Obviously cycle. No, obviously truck, right? So this is a momentum. Now momentum is related to the second law of that Newton's laws of motion. So just come to second law of motion. It says that if a body has some momentum and we are applying some force on this particular block, so the force applied on that particular body or block, that will be equal to the rate of change of that linear momentum, what we studied in the last slide. That force, that is equals to rate of change of linear momentum, and we have studied that this momentum is equals to mass into velocity. So we can simply write d by dt mass into velocity. In most of the problems, mass is just constant. Most of the problems, I'm not saying on all the problems. In most of the problems, mass is constant. So mostly mass is constant. If mass is constant, so we can simply take it outside the differentiation. So F will be equal to m dV by dt, dt. So what is dv by dt? What is dv by dt? dv by dt is simple acceleration, so we'll simply write f is equals to m into a. This is also called the second law of motion, or second equation of motion. Got it? Very good. Okay, now you know all these things from your class 9, so I'm not just taking too much time in f is equals to ma. We can simply say that you just know this f is equals to ma. Now what is the problem solving technique? Now we'll just simply focus on this thing, because this is a major thing which is going to be appear in your JEE examination, that that f is equals to not this f is equals to not f is equals to ma, not ma. F is equals to ma is not going to be just asked in your JEE examination, that what is the second equation of motion, write the expression of that particular, that is just going to be, that can be asked in your board examination, but that is also just chances, that rare chances in the board examination. So what is the problem solving strategy? We'll just talk about that. Suppose that we have a system, because now we are just going to solve the problems, because NLM is all about the problems. If we'll not solve the problems, we'll not just going to learn the concept. If we have to learn the concept, we'll have to solve the problems. So how we'll just approach a particular body, or how we'll solve a particular problem? There are three major steps. We'll just talk one by one. First of all, if there is a system, whatever the system is, it is a pulley block or whatever it is, we'll have to just select the body. First of all, we'll just select the body. Now we'll identify all the forces. We'll just write all the forces, F1, F2, F3, whatever it is, mg force, normal force, tension force, whatever it is, we'll just have to write the force. Now third thing, we'll have to make a free body diagram. Means just we have marked the forces, it means it has become a diagram which is called a free body diagram, in which we are showing all the forces. Now we'll just write the equations of those particular things. Aligned, totally aligned till here. Okay, now we'll just try to apply these things in a particular question. Okay, now this is a surface on which two blocks are kept. One is 2 kg, other is 3 kg. We have to calculate the normal between them. So first of all, how we'll calculate the normal between them? Since there is one force is being applied on this particular system, so first of all we'll calculate how fast is moving, or what is the acceleration of this particular system. So we'll approach like this. Okay, so this is a system. I'm just considering it as a total system. So I'm just considering it 5 kg block, 5 kg total. What are the forces? We just have to follow the steps. This is 50 kg. This is normal. We don't have to talk about this, because this is not our topic to be asked. Okay, this is 50 newtons. And this is just moving. This is moving. So suppose the acceleration of the system is a, so we can simply write 50, that is equals to 5 into a, means acceleration is what? 10 meters per second square. So first of all, we have calculated the acceleration. Now we have to calculate the normal between them. We have to calculate normal between them. So first of all, let us think about the second wala block. Now just look at this second wala block. This is 3 kg. This is 3 kg. And you have to just think about it, why this block is moving, why this second, exactly. So why this second block is moving? If we are applying the force on this second wala block, if we are applying this force on the second wala block, it means this, or we should put another block too. We should put another block too, and we are pushing this particular wala block. We are pushing this. Can you see this? Can you see this? Or we should take some other thing. We should take some light color thing. Okay, I'm taking this duster. Okay, just look at this. Since I'm pushing this wala block, I'm just pushing this wala block. So this is moving. This is just bonus. This is just moving because this block is applying some normal on this particular block. So this block is moving just because of the normal which is being applied by this particular block on this white wala block. Got it? Any doubt? Exactly. Acceleration is equals to 10 meters per second square. Now we have calculated the acceleration. Now we'll just calculate the normal force. So this block is moving. I have already told you that this block is moving because of the normal applying by this particular 2 kg block. And the acceleration of the block is 10 meters per second square. So this normal is the only force which is being acted on this particular block in the horizontal direction. So we can simply say force is equals to mass into acceleration, means 30 Newton is the normal direction applied by this particular block on this block. So this is the normal direction we have to calculate. Got it? Got it? Similarly, another kind of this kind of problem, you can also solve this. So what is saying, find the contact force between the blocks and the acceleration of the block as shown in the figure. Since there are some forces and we just have to apply the same concept, that this total system is 5 plus 3 plus 2 means 5 over 10 kg block. What is total force? This is 50 Newton, this is 30 Newton, and suppose the acceleration is a. So what we can write, the total force is 50 minus 30. So 50 minus 30, that is equals to mass into acceleration means 20, that is equals to 10a. 0 0 got cancelled, a is equals to 2 meters per second square. Since we have got the this is a simple process. First of all, you have to calculate the acceleration. We have to calculate the acceleration. Good. So we have to calculate the acceleration. Since we have calculated the acceleration, now we have to calculate the normal or contact forces between the blocks. Okay. Now first of all consider this particular, or first of all consider this particular block, this 2 kg block, this two, step by step. You have to go step by step. We are not considering the perpendicular forces or vertical forces, because those will be cancelled out because of the mg. Got it? Now this is 50 kg, this is 50 Newton, and there should be some normal reaction applied by this 5 kg wala block on this. So this, suppose that this is n1 and this total system is going in this direction with 2 meters per second square. 2 meters per second square. Okay, boss. Okay, so write the total force. So what is the total force? 50 minus n1, that is equals to 50 minus n1, that is equals to mass into acceleration means 2 2s are 4, mean n1 is equals to 48 Newton. We have got the normal reaction applied by this 5 kg block on 2 kg. Now come to the 5 kg block. Now come to the 5 kg block. This is 5 kg block. This is 5 kg block. So 5 kg is applying 48 Newton on this. So 2 kg will also apply 48 Newton. 2 kg is applying normal reaction, N2 or 48 Newton, and this 3 kg wala block. This 3 kg wala block is also applied the normal on this particular body. So what is the normal? Suppose that this is N2. This is, or I have already written N2, right, I think. No, this was N1. Okay. So the acceleration is 2 meters per second square. Acceleration is 2 meters. So just write the equation, 48 minus N2, that is equals to mass into accelerations means 48 minus 5 to 10, that is equals to N2, means N2 is equals to 38 Newton. 38 Newton. Got it? 38 Newton. Since we have got the N2, now we have to calculate the normal reaction on this particular block. Just check it. This is the third block of 3 kg. Since this is applied N2, so this will be also applied N2. What is it? 38 Newton. And this is of 3 kg, 30 Newton. 3 kg, 30 Newton. 3 kg and 30 Newton. 30 Newton. Okay. And this is moving with acceleration. Oh, sorry. Oh, we had already find N2. So we don't need to do further calculation. We had find N1 and N2. We just khatam. Finished. Okay. Very good. Great. Okay, let's move on to the next thing. Okay, now we'll go to the pulley block system, because we have already studied pulley block in the constraint motion, and we just had solved that particular constraint wala portion in the pulley block system. Now we'll go to the force equation, or we'll just apply the force equation and solve the acceleration for the tensions, all the things which are being asked in this particular system. So we'll just solve those things. Okay, how will we solve? So first of all, suppose that this pulley is at rest. And we have to calculate the strings, the acceleration of the block and the tension in the string. How we'll calculate? We'll just simply write the individual blocks and write all the forces on this particular things. So this is what? 40 Newton, correct? mg. And this is what? Tension. So tension on this particular complete pulley. So this is also tension. This is what? 20 kg. So 20 Newton. Suppose that the acceleration is a. So obviously this is 4 kg na, and this is 3 kg, so it will be moving like this. So first of all, we'll write the equation on this particular 4 kg. So this is going in the downward direction, means 40 minus what is stopping? It is tension, that is equals to what is mass? 4, and acceleration is a, 4. Equation number 1. Second equation on this particular block, it is going upward, so this will be larger. T minus 20. T minus downward force is 20, that is equals to mass into acceleration is what? A. Acceleration is what? A. So 2 into A. Equation number 2. Okay. Just add these two equations. Just add these two equations. What will be left with? 20 is equals to 6A. Means A is equals to 20 by 6 means 10 by 3. 10 by 3 meters per second square. 10 by 3 meters per second square. 40 Newton. 40 Newton. 40 Newton. Where 40 Newton? This 40 Newton. Excuse me. This 40 Newton. This is 4 kg. So if there is any block, of 4 kg, so this is what? There is some gravitational attraction. Because of this gravitational attraction, this is what? Mg. What is M? M is 4 and G is what? 10. G, well, basically the exact value of G is 9.8, but that is approximate value of G, means that is 40 Newton. Okay. And similarly that 20 Newton, that M is 2 and G is 10, so mg is equals to 20 Newton. Okay, so this is the acceleration of these particular blocks. Now there is a catch. We have to find the value of tensions also. It is written here, calculate the acceleration and the tension in the string. So how will we calculate the tension in the string? So we'll just consider one equation and substitute the value of acceleration in any one equation. Suppose that we are taking this equation, this second wala equation. So t minus 20, that is equals to 4 into acceleration is what? 10 by 3. So what is tension? Tension is equals to 40 by 3 plus 20. 40 by 3 plus 20 means this is 6 and it will become 100 by 3. 100 by 3 Newton. 100 by 3 Newton. Great. So this is 100 by 3 Newton. But there is a catch. Now we'll solve these problems in seconds without touching the pen. Without touching the pen, we'll just solve this problem. How? Let me tell you one thing, that this problem can be solved. This kind of problem, any kind of problem, it can be solved with very ease. This was 4 kg, this was I think 2 kg, right? This was 2 kg and this is 4 kg, okay. And pulley is fixed, okay. This is 2 kg, this is 2 kg and this is 4 kg. This is 4 kg, right? This was 40, this is 20, correct? Correct? Now look at me look at this. This is going with A, this is going with A. Now just imagine this system. Suppose that this is the system. Suppose that this is the system, and suppose that my neck is pulley. Now look at this. Suppose that this should be shown. Now since this is going in this direction, this is going in this direction, it means it is going upwards, it is going downwards. But look at the tension first of all. What is the direction of tension? Here, the tension is here, T, also T. Now if we just remove the system like this, and I should show you like this, this is the system, it was like this and I have now removed it. So on this particular block, there is a force of 40 Newton in this direction. So if we make it like this, so this was 4 kg, so there is a 40 Newton on this direction, and there is a 20 Newton on this direction. And this was tension and this was tension. Tension got cancelled. And suppose that the acceleration is A. So what is it? What is the total force? Total force is 40. Total force is what? 40 minus 20. 40 minus 20. That is equals to, what is total mass? 4 kg plus 2 kg means 6 kg. 6 into acceleration. So acceleration is what? 20 by 6 or 10 by 3. This is a direct method. You just have, you don't have to take all the tensions in the play. If it is asking the tension, then you have to solve any FBD diagram, or you just have to make any FBD diagram on any block. You can find the tension also. Got it? So this is the main approach of solving this kind of problem with very ease, and you can find the answer with very ease like this. Got it? Now let me tell you one more thing. Yeah, this is the problem. This is one of the, I should say, not very conceptual but very calculative problem. This is also in HC Verma. How we'll solve it? What is the approach of this particular question? Let me talk about this. This is fixed, okay, and this is movable pulley. I've also written the acceleration, the relations between these acceleration in the constraint motion, right? So this is 10 kg. Suppose this is going in this direction with acceleration A1. If we just mark the acceleration, suppose this is going in direction A2 and this is going in direction with A3. Okay, now just draw all the forces. So there will be, let us focus on this 10 kg. This is 10 kg, this is tension, there is tension of 100 Newton in downward direction. Mg, 10 into 10. Now suppose this is what, 20, this is what, 40, right? Like the previous problem. This is tension T, this is tension T. Now look at the pulley. These tensions are TT, means on this particular point there will be tension 2T. There will be tension 2T because this tension will get added by this pulley and this tension will be 2T. If that is 2T, 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 so this will be also 2T, this is 100. Got it? So on the first block there is 100 and there is 2T. And acceleration is what? A1. So if we want to write the equation on this particular block, we'll simply write 100 minus 2T, 100 minus 2T, that is equals to, what is mass? 10 kg into acceleration, means 10 into A1. Equation number 1. That's how we'll start making the equations of this thing. Great. Now, just come to this block, just come to this particular block. This block is going upward with acceleration A3. So we can simply write that T minus 20, T minus 20, T minus 20, that is equals to mass into acceleration is 2A3. Equation number 2. Equation number 2. Now come to the third block. It is going downwards. It is going downwards means 40 minus tension. 40 minus tension. 40 minus tension, that is equals to mass into acceleration, means 4 into A2. 4 into A2. This is equation number 3. Now just look at the beauty of this question. We have here how many variables? How many variables? A1. Just count with me. A1, A2, A3. And tension. There are 4 variables in these 3 equations. Can we solve 4 variables in just 3 equations? Is it possible? It is just impossible to solve. Mathematics wale sir, you have told now, they have told now that it is impossible to solve those 3 equations for 4 variables. If there are the n number of variables, then there should be n number of equations to solve for those particular variables. Got it? Now, since there are 4 variables and 3 equations, we just need one more equation to solve these problems or solve these equations. So how we'll get that extra equation? We'll just get that extra equation with the help of that constraint motion which we have learnt in the beginning of the session. So how we'll just write this? We'll just simply say that if this is going downward acceleration A1, this is going with acceleration A1, it means the pulley is going upwards with A1 also. Okay, this is going with A1, pulley is also going with A1. Now look at this pulley. Now look at this pulley. Okay, this is going with A1. This is going upwards with A3. This is A3. And this is going downwards with A2. This is going downwards with A2. Now I have told you in the constraint motion, where I have told you in the constraint motion that how we'll find the relation between A1, A2 and A3. Just mark the points. Just mark the points which are connected, which are the endpoints. So this and this. These are the 4 points we always mark in this kind of system. So what it is doing, this point is going upwards. So length is being decreased, means acceleration will be negative, means this is minus A3. This is minus A3. Now this point is going upwards because the pulley is going upward. So this point will increase the length of the string. It means there's a positive. So plus A1. Similarly, this also going upwards. So length is increasing, means plus A1. This is going downwards, means length is increasing, means plus A2. That is equals to 0. So what will be left with? We'll be simply left with 2A1 plus A2. That is equals to A3. This is equation number 4. This is equation number 4. Now we have 4 equations. Can you solve these 4 equations for A1, A2, A3 and tension? So we can simply solve this equation. This calculation is not going to be easy. Not going to be easy. You'll have to sit for it. You'll have to solve for these 4 equations. I'm not going to solve these mathematics problems. So this you can solve at your homework. This is your homework, that you have to solve these 4 equations for 4 variables. Physics, I have told you that how you have to approach this problem, how you will write the equations on each block, how you will use the constraint motion to find the final equation. Now you have all the equations, all the variables, all the things you have in your hand. You know the mathematics. You have to just solve the equations. Easy peasy. Got it. Great. So this is the kind of problems you have to solve. Now I've already solved this. Okay, before coming to the third law, I want to demonstrate some other examples also. Just be with me. Just be with me. Now, suppose that I'm giving you a problem. Suppose that I'm giving you a problem like this. Like this. Let me think a problem for you. Let me think a problem for you. Let me. Oh, this is a block. This is a pulley. This is a block. This is a pulley. This pulley is fixed. This pulley is fixed, and there is a block connected with it. There is a block connected with it. Suppose that this is 2 kg. This is 1 kg, or I should write this should be suppose that 5 kg. 5 kg. This is 1 kg. We have to find the acceleration of all the blocks. We have to find the acceleration of all the blocks. How we'll calculate? We just have to do all the things which we have done in the last problem. Like, we have two things. First of all, equation of motion, Newton's laws of motion, with which we can write the force equations or ease the block. Then we have constraint motion. So for constraint motion, you have to select a string. For force equation, you just write all the forces on the particular blocks. So first of all, we'll just solve for the forces. I'm not writing the constraint right now. First of all, I'm writing all the forces. So this is 2 kg means 20 Newton. This is 5 kg means 50 Newton. And this is 1 kg means 10 Newton. But this 10 Newton is unnecessary because the normal reaction is cancelling this 10 Newton and this is not moving in the vertical direction. Do you agree with me? Okay. Now look at this. If this tension is T, if this tension is T, so this will carry forward, and this is T, so this is T and this is also T. Now look at this pulley. This is being applied by two forces, tension T and tension T. These are two tension T's. Means these will get add up and this will become 2T. This will become 2T. T, 2T. T, 2T. Got it? Now, write the force equation. Suppose this block is moving downward with acceleration. Suppose at A1. This is moving with something A2. This is moving with something A3. Now we'll just write all the things, all the force equations. So first of all, I'm writing on this. So what will be the force equation? 50 minus 2t. 50 minus 2t, that is equals to mass into accelerations, means 5 into A1. Equation number 1. Equation number 1. Let me remove my watch. It is creating some problem. Okay, now freehand. Now come to this block. This is going upwards, so tension will be larger, means T minus 20. That is equals to mass into acceleration, means 2A2. Means 2A2. Equation number 2. Now come to third block. This block is moving in the horizontal direction. This block is moving in the horizontal direction. We will just not focus on the vertical forces. We'll just consider the this horizontal forces. What is the horizontal force? Total horizontal force on this particular block? That is only T. That is only T. Yes or no? So T. That is equals to mass into acceleration. What is mass? 1 kg into acceleration is A3. Means only A3. Equation number 3. Equation number 3. Got it. Now we have to solve for the these are the what? 3 equations, but variables are 4 because T, A1, A2, A3. These are 4 variables, but equations are 3. So we just have to make the 4th equation with the help of constraint motion, and with those 4 equations we'll solve for A1, A2, A3 and tension. Aligned? Now come to the 4th equation. How we'll solve the 4th equation? We'll just use a constraint motion on this wala string, on this wala string, on this wala string, on this wala string. We'll just use the constraint motion. We'll just use the constraint motion. So just first of all, mark the points of which are connected. So 1 point, 2 point, 3 pointer, 4, 5, 6, 7, 8. We just mark the end points. Okay. Now. This block is moving upwards with acceleration A2. So this length will be decreased, means minus A2. How we'll write? Minus A2. If the length is decreasing, that acceleration is negative. If the length is increasing, then the acceleration is positive. Okay. Now, this point and this point are connected with the pulley, and the pulley is at rest. So these points are not moving. Now come to this. This block is moving into the A1, means pulley is also moving into the A1, means these points are also moving into A1. So these are increasing the length, means plus A1 and plus A1. Okay, now this pulley is at rest, so just don't consider these points. Now come to this point. This is moving in this direction with A3, and this is just reducing the length of the string. It means minus A3. minus A3, that is equals to 0. So what will be left with? We will be left with 2A1, that is equals to A2 plus A3. This is equation number 4. Now we have 4 equations. Now we have 4 variables. Can we solve these 4 equations with the help of, so now solve for these 4 variables with the help of these 4 variables. Now simply this is mathematics. Now this is simply mathematics. Yes or no? Please write in the chat section. Chat section is only for you. Just write in the chat section. Can you solve these 4 equations for these 4 variables? You have to find A1, A2, A3 and tension. You can simply find all these things. Got it? Got it? Hello, hello, how are you? Got it? Should we move on to the next thing? We should move on to the next thing. Now, I'll just explain the Newton's third law before coming to the next problems. What is the Newton's third law of, what is the Newton's third law? What is the Newton's third law? Great, very good, very good. You can simply say that 2A1, that is equals to A2 plus A3. I'll just take 2 minutes for explaining this Newton's third law, because we are using this thing, but we are not explaining because we simply know from our 9th class or 8th class that what is Newton's third law. If I just give you a slap, you can also, no, you will not give me a slap. I know you respect all the things. So if I'm just applying the force on this particular table, then the table is also applying the force on my particular hand. So that is the action reaction pair. If why this rocket just moves up, because there are some gases exerting out in the downward direction. So it should balance, there is no external force, so this should go upwards to balance the momentum. So this is the Newton's third law, that there are action reaction pair, all the forces. Got it? I'm not just taking too much time to explain this third law, because you are just learning this third law from your not childhood, but class 7th, 8th, you just start learning these kind of things. Okay. Okay, this is a simple example that the Ram and Shyam are just pulling this string in opposite direction. So this string is also just applying some tension in the opposite direction. So this is some example. Okay, I'm not going to detail of it. Okay, now this is some good problem. This is a good problem. This kind of problem is also in the H.C. Verma. SC book. You can also find this kind of problem. Okay, so what it is saying that we'll just read this problem. A 60 kg penter. There is a pen. Can you see the figure? Can you see the figure very clearly? Can you see the figure clearly? Okay, great. Now this is one of the good problems. So there is a painter, means suppose that you have seen in the like renovating buildings that there is some kind of trolleys in which there are some workers working on this, and they are holding some ropes. And what it is doing, it is just like this. It is just like holding the rope, and it is trying to just pull the rope in the downward direction. So if it is trying to pull the downward direction, this is connected with a pulley. This is connected with a pulley, and if I'm pulling this thing, so this, suppose this is the trolley and I am in it. So if I'm pulling this end, me and trolley both are going upwards. Aligned. Oof. Sorry. Chala. Let's move on to the next thing. So what it is doing, it is just pulling the string. So all the system is going upward. Now, what it is saying, that 60 kg painter on a 50 kg platform, this platform or this lift, whatever it is. So 60 kg, painter is 60 kg, painter is 60, no, I'm not writing. It is 60 kg and platform is 15 kg. Attached to a platform and passing over an overhead pulley allows the painter to raise himself along the platform like this it is moving. Okay, great. So to get started, he pulls the rope with force of 40 Newton. Find the 400 Newton, means he is just pulling the string with the force of 400 Newtons. It means he is up. Just listen to me very carefully. No, it is okay. Okay, so whatever. I'm just pulling this string. I'm just applying the force on the string. It means string is also applying the force on my hand. So the amount of force which I'm applying on the string, the same amount of force the string is also applying on my hand. So if I'm pushing it I'm pulling it with 400 Newton, it means the tension in the string is 400 Newton. So this is the clear figure. This is the clear figure. Okay, this is the clear figure, and I am applying the force in 400. So this is 400, so this is also, tension is also 400. So I'm just erasing it. tension is the 400 Newton. Okay, so this is tension, this is tension, this is tension, and this is connected. Okay, so if this is tension, this is also tension, this is also tension. Okay, now this is 60 kg, this is 15 kg. Suppose that the acceleration is what we have to find. We have to find the acceleration. So suppose the acceleration is A. What is the total downward force which is being applied on this particular system? What is the total force? Total force is the mg, which is acting on the man as well as the platform. So man, what is the total force on the man? 60 into 10 means 600. So suppose this is the mundi of the man, head of the man, and there is a 600 on the man, and this is a trolley, and this is 150 mg, right? So total force is 750 Newton. So we'll just write simply the force equation. So total force in upward direction is T plus T, means 2T minus what is the total force in downward direction? That is 750 Newton. That is equals to mass into acceleration. What is total mass? Total mass is 60 plus 15 means 75. 75 into acceleration is A. That we have to find. Now, two variables but one equation, but we know one thing, that tension is given as 400 Newton. So we'll just simply substitute the value of tension here. So 200 into 2 means it is 800 minus 7, just let me put 800 minus 750, that is equals to 75A, means this is 50 divided by 75, that is equals to A. So A will be equal to 2 by 3 meters per second square. Any doubt? Should we move on to the next thing? Any doubt? Just look at this thing. I'm just going out of the frame, so just look at this. Just think 1 minute that what I'm doing, I'm just applying all the forces. This just looks a bit scary problems. Exactly. So this just looks a scary problem, but it is not if you just know that how to apply all the forces and how to use the equation, how to use the law of motion, how to write this equation, how to substitute the values. Then this is just a bread and butter for you, right? Just note it down, and we will be moving to the next thing, and I will be solving some more problems. I'm just giving some more problems. One thing, if you are new to this session, if you are new to this channel, just hit the like button and don't forget to subscribe to the channel for this kind of content. And one more thing, you can just check out the channel. And one thing I must tell you, that this series had a lot of potential, because in this series we are covering the total theory, entire theory in one session. And the other thing, and the one surprising thing, that we are covering all the PYQs, all the we have done the session of kinematics. Firstly, we did the session of kinematics. We solved all the PYQs of kinematics from 2002 to 2024. Similarly, we'll solve all the problems for the laws of motion from 2002 to 2024. So this session, this series, I don't think there is any series which is solving this range of problems, 2002 to 2024, like this, in English especially. In Hindi, we are also doing on the JEE Infinity channel. If you are a Hindi student, you can also go to the JEE Infinity channel, where I'm also solving these kind of problems in Hindi, but on this particular channel I'm doing in English. So you can, if you're an English student, then this channel is a blessing for you. This is a Santa gift for you if you are first time on this particular channel. So just write it down, and we are moving to the next thing. Let me give you some more problems. Don't worry, miss. We'll be taking all the classes, don't worry. Friction, firstly I thought that I will cover in this section, but friction I'll take in another section, so don't worry. But PYQs we'll be doing together. Friction plus complete this section. In this session we are just covering without friction wala portion. Okay, so just give me 1 sec, and just let me write one more problem for you. Just let me write one more problem. Suppose that this angle 53, this angle is 37. So we are just a second. Yeah, what I was saying, this is 53, this is 37. Suppose that this is a pulley, this is the pulley, and there is 2 blocks. These are the 2 blocks. One is of 2 kg, one is of 4 kg, and these are connected with a string. And we have to calculate we have to calculate the acceleration of these blocks. We have to calculate the accelerations of this block. Suppose that this block is moving here is A, so this will be also moving here with A. This is, I don't think this is any problem, that the acceleration should be same, because there is only one string and it is constrained to move like this. Aligned? Okay, now just mark the forces. So suppose that this is 4 kg, so what will be the mg on this in the downward direction? That will be 4 into 10 means 40. On this it is 20. Now we'll just make the components of these forces. So if this is 40 and this angle is 37, if this angle is 37, let me write it very clearly for you. It is 37. So suppose that I draw this component of this 40 Newton. If it's 37, it is 53. So it is also 37. So we'll just make the components of this 40 Newton along this and along this. So this is what 40. This is what 40 cos 37. This is what 40 cos 37. So cos 37 is 4 by 5. Cos 37 is 4 by 5 means 40 into 4 by 5. Similarly, here it is 40 into sine 37 means 3 by 5. Correct? So 5, 8, 32, and it will be 24, I think. Yeah, 24 Newton. So this is the force acting on this particular block. Similarly, just make the components of this. So this is 53. This will be also 53. So this is what 20 cos 53 means 3 by 5, and this is what 20 sine 53 means 4 by 5. 5 4 is 20 means this is 16 Newton, and this is what 12 Newton. Got it? Now we have to find the acceleration. One thing I've already told you, that if you have two things and you have like two blocks over a pulley, then this is just a bread and butter for you, because you can just take as a system and just mark the forces and just balance the forces. So if he's not asking about the tension, just ignore this, because this tension at this tension will just cancel each other. So we'll be simply writing with 24 minus, because look at this is being pulled by the tension. This is I haven't written anything wrong. 40 sine 30, there is no 30, this is 37. This is 37. So this is 24 and this is 16. So 24 16 means 24 minus 16 is the total force. 24 minus 16 is total force, and that is this I'm doing very shortly. Like you should write all the, let me tell you first of all very like systematically. So first of all, on this particular block, this block is moving like this. So 24 minus tension, that is equal to mass into acceleration means 4a, and second equation on this, that T minus 16. So T minus 16, that is equals to mass into acceleration means 2a. So solve these two equations. What will be left with? Will be simply left with 8, and this is 6. So a is equals to 4 by 3 meters per second square. But if we want to solve it directly, okay, I can try, but on this session, on this channel we are doing a series for 2026 as well as 2025 students. What is the perks of 2025 students? So for 2025, we are doing the PYQ series, in which that we are completing all the PYQs for all the chapters from 2002 to 2024. That is the perk of this particular series. Okay, so what I was telling, that mark the total forces. There is 24, there is 16. So what is the net force? 24 minus 16 means 8. So 8 is the total force. That is equals to mass. What is the total mass? 4 and 2 means 6. So 6 into acceleration. What is the acceleration? You can directly write acceleration is 8 by 6 means 4 by 3 meters per second square. So you can directly write the acceleration with this kind of thinking. Because if you are thinking like this, then it will be like the bread and butter. I'm using this word again and again, but it will become bread and butter for you, because NLM is all about thinking, and it is all about concepts. It is not just about just memorizing all the things. You'll have to think that what shortest method I can apply on this particular thing. Got it? Okay, let's move on to the next thing. I'm just giving you one more problem. Just try to solve this. Just try to solve this. this angle is suppose that 37 degree. There is a pulley, and this block is of 4 kg or 2 kg. Suppose that this block is of 1 kg, 1 kg, and you have to now this is your homework. This is your homework. You have to. This is your homework. This is like similar problem, like this. You have to solve this problem, and you have to find the accelerations of this block. Find acceleration. Find acceleration. Acceleration. Okay. Okay. So now I'm just giving you a. You can also solve it here because I'm giving you a 10 minutes break. Because I'm also giving you 10 minutes break for water and whatever it is you can do in 10 minutes break, and we'll be returning with something good, some good problems, and just stay tuned. And if you haven't subscribed the channel, please subscribe the channel and click on the notifying button. Okay. Okay, I'm back. Calculation mistake किसमें? Should we move on to the next thing? We should move on to the next thing. Definitely. Let's move on to the next thing. Okay, this is done. Spring force. Now we are moving to the spring force. Spring force is one of the most important force because it comes in an NLM, it comes in work power energy, it comes in SHM. But in in NLM, basically laws of motion, I have, like, if I have done PYQs from 2002 to 2024, there are hardly 4 to 5 questions in like 150 questions. 5 out of 150 questions. Means the weightage of the spring force is not that much, so but we have to cover all the things, so we'll just start the spring force. What is spring force? Suppose that we have a spring, you know all spring, like, which is also in your notebook, spiral notebook, that is helical notebook, by the way. So we have spring and we have just one block connected with the spring. Now if we just pull, pull this block with the force F, suppose that this is a natural length. This is the natural length of the spring. This is the natural length. I don't have any spring here, but I want you to let me show you the spring. 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 Spring. Give me one sec, dost. Give me one sec. So that I can tell you very in a beautiful way, very beautiful way. So suppose that I have this spring. Okay, so suppose that we have a spring mass system. Just guys, look at this. Vijay Roshan, we are also doing the PYQs on the English channel. Just check the playlist. We have started this series. So what I want to show you, that we have a spring. Guys, look at this. This is a spring. Suppose we are just focusing on one spring. There are 2 springs in this setup. So just look at this thing. Suppose this is the spring. Suppose this is the spring. And in this section, this is the natural length. What is this called? This is called the natural length. Natural length. This is the natural length. Means this is just a spring without any mass. Now what we do, we just simply take a mass, or suppose that 250 gram, or just take the 100 grams mass and put it on this. So it will just get stretched, and we just find the equilibrium position. We'll just found the equilibrium position. Means if we just try to stop this on the equilibrium position, this is the equilibrium position. Got it? Previously, where it was, previously the level was this. Previously, I'll show also the natural length. This blue thing. Can you see the? I'll just mark this. So this is the natural length. This is the natural length, and this is the equilibrium position. This is the equilibrium position. This is the equilibrium position. So there is a difference between natural length and equilibrium position. First of all, you'll have to understand this thing. Got it? Now, suppose that we have a spring. Suppose that we have a spring like this. Suppose that we have a spring like this, and this is the mass. This is the mass. Now what happens is, in this section, like if we have spring in a vertical direction, there the natural length and the equilibrium position are at different places. They are at different places. But in this setup, in a horizontal position, the natural length and the equilibrium position are at the same points. This is the natural length as well as equilibrium position. So you have to understand the difference. First of all, what is the natural length, what is the spring force, sorry, what is the equilibrium position. Okay, suppose that this is the extension in the spring. Suppose that this is the extension in the spring. Okay, now look at this thing. What the force is being applied, this is 100 grams. This 100 grams means 0.1 gram. This is also 0.1 gram. 0.1 gram. Okay, this is 0.1 gram. Oh, sorry, this 0.1 kg. I'm sorry, 0.1 kg. This is 0.1 kg. Means there is a force. Acting on this particular system in downward direction, which is mg, and m is what, 0.1. The total force will be 0.1 into 10, means 1 Newton. 1 Newton is in downward direction. Now we define a particular constant for the spring. Now we define a particular constant for this kind of spring, which is called a spring constant, and that is denoted by the K. that is denoted by the K. In SHM, when you study SHM, K is not the spring constant, that is called the SHM constant, but here it is spring constant. Okay, so it is K. Now if we are applying the force on the spring, just listen to me very carefully. If we are applying a force on the spring, then look at the spring. What spring is doing? It is trying to regain its natural length. It is trying to regain its natural length. That's why there is an oscillation. There is an oscillation which starts in the spring. But suppose that, let's do not go to the oscillations part. Just focus on the force wala part. Okay, so this is the force. Now suppose that this is a spring, we are applying the force on this particular direction. So what spring is trying to do? Spring is trying to be in the natural length. That's why it is applying a restoring force. What is it applying? It is applying a restoring force in the opposite direction. In the opposite direction, and this is denoted by the Kx. Restoring force is denoted by the Kx. What is K? K is the spring constant. X is the displacement from the natural position. K is that, suppose that it was a natural position or natural length, so this is X. So this is X. Can we find this value of X? Can we find this value of X? Obviously we can find the value of X. Suppose that K is equals to 50 Newton per meter in this particular question. Okay, now it is 1 kg. We have to find the natural length. We have to find the natural length. How we'll find the natural length? Just look at me. Since it is 1 Newton is in downward direction, so there will be Kx in upward direction. This will be Kx in upward direction, and we have to find the value of 1. So if it is in equilibrium, then all the forces will be balanced. Yes or no? It means Kx that is equals to Kx is equals to 1. And what is the value of K? What is the value of K? This is what? 1 Newton in SI unit. Okay, so X is equals to 1 by K. K is what? 50 Newton per meter. It means it is in meters. So we can also change it into centimeter, means multiply of 100. So it is in centimeter now. So it is what? 2 centimeter. So if the spring constant is 50 and the mass is 100 gram, then the extension in the spring, or we can say the equilibrium position, is separated by the distance of 2 centimeter from the natural length. Got it? Any doubt till here? Any doubt till here? Now. Suppose that we just, what we do, we just simply attach some other mass. Suppose that some other mass, attach some other mass to this spring, and we just keep it on the natural length. You can simply see that the extension will be more. The extension will be more, and if we just leave it, because of those forces, unbalanced forces, it starts just SHM. It just starts SHM. Got it? So this was about the spring force. Now one thing I want to show you about the spring, I want to tell you about the spring, that suppose we just remove the mass of the spring. Just remove. Suppose that I just remove this mass. So what it does is, it suppose that there is mg force. There is mg force on this particular thing. There is a mg force. This is mg, and this is kx. This is kx. Okay. What happens is, suppose that it was a string. Suppose that there is a string. There is a string, and there is a block, and this is also 100 gram, and this is the mg. This is the mg, and there is a tension. What happens is, just look at me, just listen to me very carefully, that when, suppose that this mg is removed, or this mass is removed, what happens is, tension becomes zero suddenly. As soon as we'll remove the mass, the tension becomes zero. As at that particular instant, the tension becomes zero. So as mg is removed, tension becomes zero. Just note it down. If as mg is removed, tension is removed at that instant. Okay, but listen to me very carefully. When we remove mg in this, here we are talking about the string. There we are talking about the string, but here we are talking about the spring. So if we remove this mass, tension doesn't get, sorry, this is not tension, this is kx. Spring force doesn't get zero. This doesn't get zero. It remains here, and spring just get up. Spring, you can imagine it. We just removed here. Let me just first of all note it, otherwise it will be like just vanished. So just take a screenshot, and we are moving to the next. So now, as soon as we just remove the mass, it goes up, but it doesn't happen in the string, right? It doesn't happen in the string. Agreed with me? Now this is the major difference between this spring and string. Now we'll just take the benefit of this and we'll solve some problems on this. We'll solve some problems on this particular thing. So first of all, what the question is saying? Question is saying that find out the acceleration of 2 kg block in the figure shown at the instant 1 kg block falls from the 2 kg block. There is a spring and a string, okay, and on the 2 kg block there is a 1 kg block kept on that particular block, okay. Now what it does, we just suddenly remove, like I'm standing here, I'm standing between these two things, can you see me? And I just remove these two things suddenly, I just remove these two things suddenly, and what happens is you have to find the accelerations of 2 kg block. So first of all, let us talk about the spring. First of all, string. Let us talk about the string first of all. String. Okay. What happens in string? This is a string. This is a 2 kg block. This is 2 kg block. This is 1 kg block, and it just falls down. And if it falls down, there is first of all, what it was? There was a total 20. Means 2 into 10, 20, and 10 means 30. There was a 30 Newton force. And here the tension. So here tension was 30 Newton. Tension was 30 Newton. But as well as, or as soon as we just remove this 1 kg block, as soon as we remove this 1 kg block, this becomes 20. This becomes 20, and tension suddenly becomes 20 Newton. It doesn't take any time to switch from 30 to 20. It suddenly transforms from 30 to 20. But in this case, in spring, what happens is, if we have a spring, and this is a 2 kg and this is a 1 kg, the total is 30 Newton, and upper is kx, and I'm just writing it, kx is equal to 30 Newton, okay, kx, and there is a force of 30 Newton. But as well as I removed that 1 kg wala block, there is a force of 20 Newton. But what happens is, what the catch of the spring is, just listen to me very carefully, that this 10 Newton in the downward direction has been removed, but it also remains here, means it remains here as 30 Newton. So downward there is 20 Newton, upward there is a 30 Newton. So there is a force difference towards the upward direction of 10 Newton. So there is a total force of 10 Newton, and there is a mass of 2 kg, means acceleration is 5 meters per second square. So the acceleration of this 2 kg block, this string wala 2 kg mass, this becomes 0, because as we removed 1 kg, it doesn't move because acceleration is 0. But when we remove this, it goes upwards with the acceleration of 5 meters per second square. Any doubt till here? Should we move on to the next thing? We should move on to the next thing. Now I'll just giving you a cutting problem, spring cutting problems. Spring cutting problems. What are these kind of problems? Suppose that I'll just give you example. Suppose that we have a spring like this. We have a string like this, and then we have a spring like this. Then we have a spring, and there are two blocks. This is of 2 kg. This is of 1 kg. Suppose that this string is cutted here. We just have a cut from here, right? What it is being asked, that you have to find the acceleration of these two blocks. You have, as we cut this string, you have to calculate the acceleration of both the blocks. Acceleration when we cut the string. Both blocks ka batana hai. We have to calculate the acceleration on both the blocks. Okay, now just look at this. What is it? 1 kg means downward is 10. If downward is, can you see this? Yeah, 10 Newton. So if it is 10, so upward is also 10, means here is also 10. Can you see this? Okay, so it is 2 kg, it means it is 20 Newton in downward direction. So upward total is 30. Understood? 10, because of this 10, spring is being pulled by the 10 Newton force. So upward is also a 10 Newton force, acceleration pair. Now it is also has a mg of 20 Newton. So total force is 10 plus 20 means 30 Newton. Okay, now we have cut this string. If we have cut the string, the tension, becomes 0 suddenly. This becomes 0 suddenly. Now we have to look at this data. Now we have to look at this data. So this becomes 0. This becomes 0. This is 20. But we know that the spring force doesn't get 0 suddenly. So this is 10 Newton. This is 10 Newton. This is 10 Newton. This is 10 Newton. Now look at the beauty of physics. Just listen to me very carefully. Look at this block. This block has a total force of 30 Newton, but there is upward 0 force. It means it has 30 Newton downward. So 30 divided by what is the mass of this? It is 2. Means 15 meters per second square is the acceleration of this block in downward direction. In downward direction. But look at this block. Just look at this. What the beauty of this is that there is a force of 10 Newton in upward direction. There is a 10 Newton in downward direction. Means it is not moving anywhere. It is not moving anywhere. It means the acceleration of this block is 0. Now you will be thinking that how is it possible that we just cut this string and it is not moving, it is not falling down? No, it will not fall down until, when it will not fall down, until what happens? Just imagine this. You have these two blocks which are connected by the spring and other is connected by the string. Now string is cut down. What happens is the upper block comes down until it reaches to the natural length. It reaches to the natural length. Now both block goes downward with same acceleration of 10 meters per second square. Let me repeat it again. What happens is, as we cut the spring, this block remains at stationary, means this block is at rest, but this block, because of this extra force, this just come down to the natural length of the spring. Now both blocks go downward simultaneously with the acceleration of 10 meters per second square, which is the acceleration due to gravity. Got it? Got it? Should we move on to the next thing? Please like the session also. If you are watching this, please like the session. Okay. Now let's move on to the next thing. Next is pseudo force. What is pseudo force? Pseudo force is basically, have you traveled in the bus? Have you traveled in the bus? We are here in Bengaluru. We often travel in the bus because that is the only public transport here in Domulur. So this is not the public. This is the bus, suppose that, and you are traveling in the bus. You are traveling in the bus, and the driver suddenly applies the brake. If it suddenly applies the brake, what happens is you are just listening to the song and just and you just become like this. It happens with you, or you are just suddenly chilling in the bus. It is not moving. So suppose it is not moving, and it just suddenly starts. So you just become like this. Okay, relating. Okay, so what is pseudo force? Have anyone in the bus applied a force on you? Have anyone pulled you? No, na. It means there is a breakdown of Newton's laws of motion, Newton's first law. Why there is a breakdown? Just listen to me very carefully. Just listen to me very carefully. What happens is, if you are traveling in a bus, so there is no one inside the bus who is pulling you or who is pushing you. Okay, but you still just, when a driver applies the brake, you just becomes like this, or on starting the bus you just become like this. So no one has pulled you. But what Newton's first law says, a body cannot move or body cannot change its states unless we apply an external force. Okay, it means there will be a ghost in the bus which is pushing you or pulling you to validate the Newton's first law of motion, that I cannot change my state until someone applies some force on myself. Is there someone? No. It means, is Newton's first law is wrong? No. Then what is the justification of this statement? How we can justify that there is a validation of Newton's first law in the bus when no one is applying force on me, still I'm moving? So how we will justify? We'll justify in the two things with the help of something that I've already told you a concept of a frame of reference. I've already told you the concept of frame of reference. What it is? Frame of reference. Frame of reference. Frame of reference. What is frame of reference? I told you in the last class as well as I told you that what is a frame. In Hindi I simply say that dekhne ka nazariya. What is it? Means point of view. In English we can simply say point of view, that from where you are watching the thing. Like if you are traveling in a bus, then if you are in the bus, then your frame is the bus, and if you're on the ground watching the bus going far away from you, then the ground is the frame of reference for you. So frame of reference is a frame from where you are watching the whole scenario being happened, right? So now there are two kind of frame of references. One is stationary, so one is inertial frame of reference, and the other is non-inertial frame of reference. So first is inertial, and other is non-inertial. Okay, what is inertial frame of reference? So inertial frame of reference is a frame of reference which is moving with a constant velocity, or which is at rest. It is at rest, or moving with constant velocity. This is called a inertial frame of reference. But what is a non-inertial frame of reference? A non-inertial frame of reference is a frame of reference which is not moving with a constant velocity, or which is accelerating. So we can simply say that it is a accelerating frame. Or we can say velocity is not constant. Okay, so there is a validation which I told you earlier, that how Newton's laws of motion is valid in the bus, where no one is applied force on you but still you are moving, or no one has stopped you but still you just becomes like this, happens with you. So firstly, it is told that Newton's laws of motion is valid in inertial frames. First of all, this is a statement that Newton's laws of motion, all the three laws, are applicable in inertial frame. So here Newton's laws of motion, NLM, Newton's laws of motion are applicable without any terms and conditions. Okay, is applicable. Okay, but there is a catch, that if there is no Newton's laws of motion applicable in the non-inertial frame, then how we will be solving the equations of NLM in any non-inertial frame? If we have a body moving in a bus, then how we'll write the equation of motion, or how we'll write the equation of that particular motion, or Newton's laws of motion? So how we'll write the equation? So there was a solution for this too, that we'll just assume an imaginary force on the object moving in a non-inertial frame, and that imaginary force which is acting on the body which is moving in a non-inertial frame, that force is called pseudo force. Let me repeat, that if a body is moving in a non-inertial frame, that there is a force which is not real, which is imaginary, but to validate the Newton's laws of motion, we just suppose that this force is acting on the body to just write the equations of motion. That imaginary force is called pseudo force. Got it? Okay, so I'm not writing the definition. I'll just solve something for you, that how you will solve the things. Just let me complete. Suppose that this is the bus, and it is moving in the direction of this particular direction with acceleration a, and this is an object kept on a table. This is an object kept on a table. This is an object of mass m. So how we'll calculate the pseudo force? So pseudo force is a force whose magnitude, first of all, magnitude of pseudo force, magnitude of pseudo force. What is the magnitude of pseudo force? So magnitude of pseudo force is the mass of the body on which we are applying the laws of motion, or we are writing the equations of motion. So mass of the body in the non-inertial frame, and multiplied with the acceleration. This is what? Acceleration of the non-inertial frame. This is the acceleration of non-inertial frame. Acceleration of non-inertial frame. Got it? Any doubt till here? It means we have found that when we are dealing the laws of motion in non-inertial frame, we can simply just say, give the excuse that there is a force which is acting in a non-inertial frame, which is called pseudo force, and whose magnitude is given by mass into acceleration of the non-inertial frame. But what is the direction? What is the direction of pseudo force? So direction of the pseudo force is is opposite to the acceleration of non-inertial frame. Means opposite to the acceleration of non-inertial frame. So just keep it in mind, and now I'll just show you some examples with which you can understand the pseudo force very clearly. That if we are sitting in a non-inertial frame, then we can simply say that the magnitude of the pseudo force, that is equals to mass into the acceleration of the body, and the direction is opposite to the body. Suppose that this system is here, so what will be the pseudo force in this particular system? Pseudo force will be in this direction, opposite to the acceleration. What is the magnitude? Mass into acceleration of the frame. Simple. Okay, now let me solve some problems for you. Suppose that there is a cart, or there is a bus which is moving in this direction with acceleration A, and there is a pendulum attached with a string to the ceiling of the bus, and it is moving in this direction. So what will happen? Let me demonstrate it to you. That we have this thing. Just look at me. Now this is the pendulum which is in the this bus which is moving with the acceleration A. So what will happen? This will, if I'm moving like this, suppose that, just look at this. If I'm moving like this, so it initially, suppose that it is, so I'm moving like this in this direction, so it will go like this. Okay, just imagine this. So because obviously there is a pseudo force applying on this particular mass in the opposite direction. So suppose that the mass is m, and it will go like this. It will go something like this. This was the equilibrium position, and it will go something like this. Suppose the mass is m. Now it is asked that if the acceleration is a, then what is the angle of this pendulum? What is the equilibrium position? What is this angle theta? So if the angle is theta, we have to just solve the equations of motion. So first of all, what is the pseudo force? We'll just write the pseudo force. Pseudo force is in the opposite direction to the acceleration, mass into the acceleration of frame. Okay, so I'm writing it very clearly that this is ma. This is the tension, so tension is T. Okay, this is theta, so this is theta. Downwards is mg. Now, just break this T. So what will be? It will be like this is T cos theta, and this is T sin theta. So we can simply write that T sin theta that is equals to ma, and T cos theta that is equals to mg. T cos theta that is equals to mg. Divide it. T got cancelled, got cancelled. It is tan theta is equals to a by g. So theta is equals to tan inverse a by g. Got it? Now, it is a one problem which is asked in this particular kind of thing. There is another problem. What kind of problem? That it is said that if a system is moving like this, then what should be the time period of this thing? What should be the time period? Okay, we are doing on this channel also. If you are a Hindi student, there we are doing on the Finity also, JEE Finity by Unacademy. We are doing on this Hindi. Here it is in English. Okay, so tan theta is equals to tan inverse a by g. Now it is asking that what should be the time period of this pendulum? If it is moving in the acceleration a? Now what is the formula for time period? Time period is equals to T is equals to 2 pi under root L by g. Now there g is the acceleration due to gravity, but there is a catch. If it is in non-inertial frame, then there is an acceleration also. And because of that acceleration, the acceleration due to gravity, g effective, whatever we can say it is. So g effective is in this direction, opposite to the tension. So what is it? Total net force because of this is m under root a square plus g square. m under root a square plus g square, and this is called g effective. This is called g effective. So g effective is under root a square plus g square, a square plus g square. So this is g effective. So here we'll put the g effective instead of g. So t is equals to 2 pi under root L by under root a square plus g square. So this is the time period. So it can be asked also. He can ask the time period. He can ask the that theta. So whatever it is. Okay. Now let us move on to the next thing. Suppose that there can be some lift problems also on the this pseudo force, and these are also being asked in the mains also. So these are very simple problems. Just let us understand very clearly that suppose that there is an elevator. You know the elevator which are being in the malls and the very big kind of things. Okay, thank you. Okay, great. So what it is that there is an elevator which is going upward with acceleration a, and there is a man which is standing whose mass is m. Now there is another case when the elevator is going downward with acceleration a, and it is also standing in this elevator. Suppose that it is standing on a weighing machine. It is standing on the weighing machine. What weighing machine reads? Weighing machine reads the normal applied by you on the floor. And how we can calculate the normal applied by me? So if I can calculate the normal applied by the ground on me, so we can simply say that the same normal is applying by me on the floor. So we will just simply write all the forces. So first of all, ground is applying normal on me in upward direction. There is a mg in the downward direction, mg, and there is a pseudo force also. Which is ma. Now. First of all, let me tell you one thing. That if you are in the non-inertial frame, I have already told you that pseudo force is always applied when you are in the non-inertial frame. You are inside the frame. So suppose that you are seeing from here. You are seeing this object, this man from here. So you will see that this man is stationary. It means all the forces on this particular man is zero, the balanced. So here we can write that N, which is the upward force, that is equal to what is downward force? Mg plus Ma. Generally what happens is if you are standing on the weighing machine, what weighing machine rates is, it simply rates your mg. But since you are going upwards in the elevator, what happens is there is an additional force of Ma which is being added in your mg, so that you just feel like I'm very heavy. I'm feeling like heavy weight. Okay, but if you're going downwards, what happens is there is a normal in upward direction, there is mg in downward direction, but what happens is the change, because we know that the pseudo force is always x opposite to the direction of acceleration of non-inertial frame, means pseudo is acting in upward direction now. So ma. Now here we can write that normal, that is equals to what is it is mg minus ma. So there becomes a negative factor of minus ma in mg. That's why you feel a lightweight when you are going downward in the elevator. So this is about the pseudo force. Any doubt till here? Done? Okay, so in this session we have covered all the basics, all the concepts of the laws of motion without friction. In the next session we will talk about with friction concepts. So for this session that is it, nothing left in this session. So I'll just take a leave for you. And why I'm not solving the PYQs? Because we are solving PYQs in the different session where we have all the PYQs from 2002 to 2024, and in that particular session we'll be solving all the PYQs of the laws of motion. Here I have told you the theory. In that session I'll tell you the PYQs. So see you there, and best of all to all of you. If you are watching this first time, just subscribe to the channel. Don't forget to hit the like button, and also click the notify me so that you can get the notification of our classes on the daily basis. Okay, so see you. Bye bye.